Hello all, welcome to my Multiplatform Adventure workshop. I want to start to thank you to everyone that's on the other side of the screen. It means a lot. I know that we've been living really difficult times, so thank you for taking the time to attend to this workshop. I also want to thank the droidCon team for once again putting this two-day event, an amazing two-day event. I've been seeing a lot of good talks, and I know it's not easy to organize an event like this, even with everything that's happening. So first, let me say thank you to everyone. So who am I? I'm from Portugal. My name is Carlos Mota. You can find me on Twitter at Mota. So since I'm on Portugal, this is way early morning, but don't worry, I already have my morning coffee. I'm the Android dev lead at With Software. I've been working with Android for the past 10 years and been playing with Kotlin Multiplatform for the past two. I'm the founder of GDG Coimbra, Google Developers Group Coimbra, and founder of Kotlin Nights, author at Hey Wonderlic and Opinions Online, a Portuguese tech blog. And I have this dream of one day having my own podcast. So if anyone is out there that also wants a podcast, to create a podcast, talk with me at the end. I'll be here to listen to everyone, and probably we can exchange some ideas. I love travel, photography, and running, and unfortunately, lately, just these last two. So we are on holidays, so let me just put my Christmas hat so I can be on the appropriate feet. That's it. I've built some materials for this workshop. I've got the slides on Speaker Deck, Multiplatform Adventure, the code on GitHub, and I created a code lab where you can follow this tutorial at your own pace. For this, the IDEs that are required are Android Studio and Xcode. Although if you want to use only on Android, you can just use Android Studio, and that's it. I'm going to tweet everything at the end. Once again, just follow me on my Twitter and you can have access to all of these materials. So since this is a workshop, let's start by the beginning. You have your Android Studio installed, and for KMM, for Kotlin Multiplatform Mobile, you're going to need a plugin. You go to Preferences, Plugins, you search for Kotlin Multiplatform, you click on Install, it installs, you reboot, and that's it. You've got KMM on your Android Studio. Of course, you can always use IntelliJ. Personally, since I'm an Android developer, I like to have everything under the same IDE. So nowadays I only use Android Studio for this. You can get the link from my GitHub. Just clone my KMM Altogether Now project. This project is structured by different steps. You've got the starter project, the logger, the network request, the database. Let's start by opening the first one. You'll need to wait a bit for the Gradle to finish. I know this will take a bit long, a couple of minutes. And of course, we can always make use of this XKCD comic. Well, when the project is compiling, let's have some fun and probably browse Twitter or watch another droidCon video. If you don't have Xcode installed, you're going to see this error message. It's going to say something like missing Xcode exception. But for you, if you want to just compile for Android, you can just uncomment all of my comments on build.gradle, and it will automatically only run for Android. This means it won't generate a framework at the end, so you can easily use your project only on Android. If you have your Xcode installed and you want to compile also for iOS, just go to the iOS app folder and write pod install so you can download all the dependencies. You're going to download Firestore, for instance. Now just hit compile and let's run the app. And you're going to wait a few minutes. On my machine, I typically wait on the first install about 10 minutes. It's on the first install. The next ones will be way faster, don't worry. In KMM defense, I'm going to use Firestore. This is a bit slow. So a big chunk of this time, it's because we're using this dependency. It's also worth mentioning that JetBrains' product roadmap, it says that until March, one of their really good improvements is going to be on the iOS side, on compiling the project for iOS. So you can expect these values to be way lower on the future. So now we wait. But let's talk a bit about theory before we dive into our live coding session. So this basically, it's the dilemma of mobile apps. We've seen it for a couple of years now. If on the one hand, we can have this beautiful castle, if we want to target Android and iOS, for instance, it's going to take us some time to build this castle. And it will also take us time to maintain this castle, to keep it up to date. The path until we reach that castle will take us some time. On the other hand, we have a lot of frameworks nowadays that can help us build this castle, but instead of a castle, they will allow us to build a house that I'm not sure if it's not going to rain in that house, but we can build it way faster, but unfortunately it will not have the same outlook that if you build it natively. We've been seeing a lot of good frameworks that have been launched since 2006 that start with PhoneGap. We've seen Ionic, Xamarin, RubyMotion, NativeScript, React Native, Kotlin Multiplatform, and I'm saying between codes because you're going to see it's not really a cross-platform solution. And most recently, we've seen Flutter. Of course, you've got a set of advantages of using one of these solutions. And I always like to say that using one of these solutions, it depends on your project. So I'm going to give you a couple of advantages and disadvantages, but in the end, this depends on your project, your budget, your team, and what you want to achieve. Typically, you use one of your hybrid or cross-platform solutions if you've got a small team, if your team is basically web developers, so coming from the web from an hybrid or cross-platform solution, the learning curve it's really small. And of course, it takes you half of the time. You're going to have just a code base, so you've got less time to build, to test, and hopefully to fix issues, unless they are platform specific. In that case, it might take a bit more. But basically, in terms of working hours, you can reduce the cost almost on half. Of course, this brings you a lot of disadvantages. The first one, and for me, one of the worst ones, it's that you're chained to the framework implementation of the UI. So, and I have a good case here. A couple of years ago, I was developing an application using Xamarin, and there was a big redesign on the iOS side. So basically, my application was looking like the old application for 5 months, 6 months. And on iOS, basically 80% of the users update on the upcoming 2 to 3 days to the new operating system. So basically 80% of my users were still seeing the old version while having a new OS. Then Xamarin needed to launch a new update. I needed to rebuild my application with this new update. I had to resubmit it to the store, and then I need to wait for users to install it. In the meantime, I lost a lot of users because they were still seeing the old UI, and all the other applications were using the new UI, and there are a lot of applications on the App Store. So basically, why keep using this one? I know this is always arguable, but performance it's not really the same. You've got a couple of layers on the middle, so sometimes you need to write some native code. If one of the platforms doesn't support a specific feature, typically they won't implement it, and you need to rely on the community or on plugins for that. Flutter, in this case, the language itself, Dart, it's not a widely used language, at least for now. I know that we're gaining a lot of new followers and a lot of people starting to use it, but it's not as trending as, for instance, Kotlin. And you're committing your project to one framework, to one language, and what will happen in 5 years' time, in 10 years' time? If you're designing a project that you know that it's going to take you a lot of time, what will happen to the framework in 5 years, for instance? What happens if the framework stops to create new updates? Are you going to develop your project and then the framework? You're committing your project to some framework, so you need to take that into account when selecting which platform to use. So what about Kotlin Multiplatform? So I say that multi-platform wasn't really platform solution, cross-platform solution, because the goal of Kotlin Multiplatform is a bit different. The goal is to share the application logic and don't share the UI. The UI can still be shared. The UI is going to be developed natively. So you just want to share small bits of application logic or the entire application logic. Another great advantage of Kotlin Multiplatform is that you're going to decide what you want to share. For instance, my approach when I started working with Kotlin Multiplatform was the same approach when I switched from Java to Kotlin. I started by having tests written on multi-platform. I've then had a new feature to develop and started to develop that feature on multi-platform. Basically, I create my network access, then I created my database layer, and step by step, I was moving to Kotlin multi-platform and see the impact on my project. At any moment, if something went wrong, I could just stop and move that code to Kotlin, to Android, and stop this update. So we've talked about this disadvantage when you're talking about cross-platform solutions. So now let's see the multi-platform part of life and see how Kotlin multi-platform solves this. So you no longer chain to the framework implementation of the UI because the UI is going to be developed natively, so no problem. New updates from the OS, of course, take time to update because you need to wait from frameworks to implement their new widgets. So we're going to develop native once again, no problem here. Performance is not the same. This is always arguable. I know that this can bring a lot of discussion, but we're going to leave it to the UI, so basically performance will be the same. Some native code needs to be right, of course, the UI. I'm always eating UI. Some device features are dependent on framework support. You have direct support to everything, although doing it on a shared model will take you some time on the beginning because it's something different and you need to think a bit different. So you can have a bigger learning curve here. Kotlin is one of the most trending languages nowadays. We've got an amazing community support, so we're going to use a language that everyone is talking about. And of course, we're going to take advantage of the full set of Kotlin language features. The language is continuously evolving. We keep seeing new updates, and you can take advantage of all of them. Once again, you've got low risk, so you can decide what's worth to share across platforms. You can start by sharing small things and then basically give it and sharing more and more things over and over again. You've got interoperability, of course, and you've got consistency across platforms. And this is really important because I've lost the number of discussions that I had between my Android team and the iOS team because someone decided to implement a cache mechanism in between or handle network errors differently. And when the Q&A team is going to validate, they see that these applications have different behavior. So basically, if you're going to have a one stack, you're going to have consistency across all platforms. Of course, this means that if you're going to have an error, you're going to have an error on all platforms. But if you see the cup as half full, when you fix an error, you're going to fix this error on all platforms. So that's a win. And of course, there is a strong investment from JetBrains, from the community. The Kotlin Lang Slack is something amazing. I've lost the times that I made there a question and someone answered me almost immediately, and it's someone from the community, from JetBrains themselves. So people are really active on pushing multi-platform. It's important to mention that it's still on alpha, so a couple of things can change on the near future. Of course, there is this strong commitment from JetBrains, but of course, since there is alpha, you may expect some issues, especially when we talk about different libraries. And this slide is from last year Kotlin Conf. Basically, it's the apps that are nowadays on production. You've got JetBrains Space. Logic index maps that shares the business logic and wrappers for C++ libraries. PlanGrid that also shares their sync logic, management, offline data. So different applications share different things. They share what they make sense on their business, their use cases. They don't try to to share everything at the beginning. They start by sharing small things over and over and over again. Once again, we're going to take advantage of Kotlin, an amazing language, concise, safe, interoperable, tool-friendly. You all know all these advantages of using Kotlin, and I can also add that it's more than just for Android. You've got Kotlin JS, you've got server-side, you've got Kotlin everywhere. And there is a small learning curve involved, and this is particularly important since we're going to talk about KMM, Kotlin Multiplatform Mobile, because it's easy to go from one language to the other. Let's just see a small example. This is on Kotlin. I've created a variable, an immutable variable, and I've made the same thing on Swift. If you look closely, the difference is on the syntax. So an immutable one on the Kotlin, it's called the val. On Swift, it's called let. If we talk about functions on Kotlin, we call them fun because we have fun. Swift, it's almost exactly, but instead it's called func. There are a couple more differences, especially when we talk about string interpolation. They don't use the $sign. When we have talked about the return types, they use the arrow instead of the double points. So we've got small differences between one another languages, but basically you can go to open the Swift syntax and search how things behave differently and look, how can I do this on Swift? It's what I did on this project. So what's Kotlin Multiplatform is when you use Kotlin in projects that target more than one platform. Let's an example. Imagine that you're going to do it on Android. You're going to add a presentation layer. You're going to add a model. You're going to add a parser, the network layer, and then you're going to implement the UI. And then you're going to do the exact same thing on all platforms. But if you look closely, this upper part, this business logic, it's going to be the same all over again. You're going to change libraries, but you're going to say to make the same request, you're going to implement the same logic over and over again. What changes? It's how you can interact with your application. So you can use your fingers if you're on a mobile, you can use the mouse if you're on the desktop. So what changes? It's the UI itself and why it should be developed natively. So let's merge everything and make use of Kotlin Multiplatform and share this business logic everywhere. I know, right? But we're talking about different platforms, and there are things that are specific from one platform to the other. So how can different platforms expect to communicate? And I'm going to give emphasis on expect because this is how it works. So basically, we're going to use two new keywords. Expect, that's declared on what we're going to call a common model. And then we use the keyword actual to say what expect really means on that platform. So if we're targeting Android and iOS, we need to say what expect really is by using actual on both of these platforms. But let's see an example. Let's imagine that I've got a small application that just has a text that says hello from Android and hello from iOS. We want to have the same thing, but we want to get this Android or iOS from our shared model. So we need to say that we expect someone to define what device name really is. So if you look at this Android Studio, this is a screenshot. You see that I've got a common main model that's inside my shared folder. And I'm going to say that I expect someone to say what device name is. So I'm going to use the keyword expect here. As soon as I write expect fan device, it's going to say, okay, you're targeting Android and iOS. You need to say what device name is on each one of these platforms. So basically, you press Alt-Enter, and it will automatically create all of the other files. I'm going to say on Android that, and if you look here, I've now moved to a different class. I'm now inside Android main. And I'm going to say that device name equals to the Android OS build manufacturer and Android OS build model. So I'm accessing SDK features right here on my shared model. Now, if I'm going to iOS, I'm going to define the exact same thing. But of course, on iOS, you're going to use UIKit UI device. So I'm going to access the framework implementation. So I'm going to use UI device current device to get the device name. So are you all ready? We're almost there. We're going to code. This is what we're going to build. I've built an application for Android and iOS. It's really simple. Basically, you've got a shot on the first tab. You've got a list of conference, and you have a list of settings that you can define. Basically, you can define that you want if you want to see online conferences or not, and you can define your username, so your name that you're going to appear on the chat. And then I've done the exact same thing for iOS. Basically, I just needed to implement the UI. And this is what I was saying, that I've done everything on Kotlin, and then I was looking at the Swift syntax and seeing how it works with Swift. The project structure is really simple. I've got a recycler view on Android, a UI table view controller on iOS. I make multiple network requests. I parse the responses. I store it locally so I can access them offline. I'm going to use the system preferences, and then there is a new step that I can migrate code to multi-platform, just to show you how you can move to multi-platform from an existing project. Typically, if we're going to do this natively, we do something like using Home for database on Android, Core Data for iOS, Retrofit, Alarmifier, Gaze, Ingestion serialization, and so on. But if you look closely, once again, the only thing that's different, it's the UI itself. So on the Android side, we've got the activity. On the iOS side, we've got UI view controller. So basically what we want to do is just to merge all of these libraries, and you're going to use now Kotlin Multiplatform libraries. And for data access, for network, for local storage, you're going to use SQLite. For network access, you're going to use Ktor. For serialization, Kotlin X serialization. I'm going to use MVP here, although you can use MVVM. My choice by MVP was because when I was trying to pitch this to the iOS team, it was easier to explain using something that they were already familiar with. So I selected MVP for this. I'm also going to use Kotlin X routines and Kotlin tests. So this is an overview of the entire architecture that we're going to build. And to make it easier, I've designed a code lab where you can follow each one of these steps at your pace. Since I'm going to do live coding, probably some parts are going to be faster than the others. Don't worry, you can just go to this link and follow everything at your own pace. And of course, if you have any question, you can ask me here on Slido or ask me at the end or via Twitter, don't worry. Don't forget, Kotlin Multiplatform projects are still in alpha, so this is a risk that you have, of course. Once again, you can decide what you want to share, so there is no problem there. And these are the links with everything that we're going to talk about. And now it's time to start our live code session. So let's just prepare. So I'm going to move here to Android Studio. And I'm going to show you live both applications. System UI, classic emulator. So this is on the Android Studio part, and I've got also Xcode here open. And I'm going to say just hello from iOS. We're live. I'm going to send this message. Message was sent, and I've received here on Android side. So this is the base components that you have on this project. This is implementing using Firestore. So there is no big logic here. I'm just going to use function that already exists, and you will see how you can migrate this code. So if we look here at our project, basically, this is a similar structure that you're already familiar with Android. We've got here an Android app and an iOS app. This is the app itself. And if we open Android app, you can see everything that we are already familiar with. So in this case, we're going to have the fragments, activities, adapters, all the Android part. If instead we open the iOS app, we're going to see the Xcode project and all the Swift files. And now we have a different folder that's called the shared one, where we've got our code. And inside this shared, this is our common model. We're going to have the Android main, common main, and iOS main. And basically here, you're going to have on common main all the code that's going to be shared. And Android main contains the code that needs to be defined at platform level. For instance, that platform device that I've mentioned before, it's defined on Android main. And I'm saying that I'm expecting someone to define it on common main. But let's start by seeing an example how everything works. Or before I start, let me just say that I've got here this build Gradle configuration file. I'm using Cocoa Pods here to download the dependencies, as you can see. In this case, I'm just going to download the Firestore. I've got a couple of implementations using here, a couple of libraries, Ktor, as I mentioned, for network access, Kotlin serialization, coroutines. I'm also going to use Kotlin X8 time, Firebase Firestore on the Android side. I'm going to use SQLite for the database, and I'm going to use multi-platform settings to store the user-defined name. Then, since I'm targeting Android, I'm also going to need to define a couple of things here. Basically, the HTTP client engine. I'm also going to use the material library here. And from iOS side, I'm going to use, once again, the Ktor for iOS and SQLite driver for iOS. So let's start by creating something really simple, something that probably most of us have already created a couple of times, and I think it makes sense to make it here as an initial example. It's to create a logger. Okay, so we're going to go to common main. We are here, and we're going to go to shared and create a platform logger class. So Kotlin file class, platform logger, and I've automatically created this file. Typically, if you have a code that's going to be defined at platform level, it's a good approach that you use the keyword platform, the prefix platform before, so it's easier to see the code and identify that, okay, this is going to be defined on Android and iOS side. So let's start by defining internal expect. So I'm expecting someone to define what platform logger is. And of course, the logger has typically 3 methods. It's going to have a debug one. We're going to use a tag for this, and then we're going to have a warning and an error. I don't want to always keep creating the same object over and over again. So I'm going to create here an object that I'm going to call it, why not, Gutenberg. And I'm going to create an instance of logger. And then I'm going to create all the logger methods. I'm going to call here the logger.debug with tag and message. And then I'm going to do the exact same thing for the warning and the error. Basically, what I'm doing here is to avoid creating over and over the same object. I'm just going to have an instance here, and I'm always going to use this every time we call Gutenberg.d or .w or .e. If you look at this class, we're going to say that it's going to say that we need also to define what's inside Android and iOS. If I press Alt Enter, this is a shortcut. It's going to say create actual class for model Android, JVM, and native. Before we go there, I just want to make something different here on the log, just to be easier to understand that we're using our new logger. I'm going to just add an emoji. Let's say this is easier to see that we're going to use our own logger. And of course, for an error, let's use the fire emoji. If we get back to this platform logger and press Alt Enter, let's use what IDE gives us and just press Enter again, and it automatically is going to create everything that we need. So we need to say what actual fund is, debug, warning, and error. Since we are on Android, as you can see, we are at Android main, so we are at Android level. That's just going to call the Android logger from log.v and use tag message for this. Once again, Alt Enter to import, and you can see that I'm now importing Android util.log. If we go to the word, we're going to do the same thing. Word, we're going to use tag and message, and now for error, we're going to do the exact same thing, but calling the error. And that's it. If we get back to platform logger, it's going to say, okay, but you still need to define for iOS main, so you also need to define it natively. So let's press Alt Enter again and create these calls. So here I'm going to just call print. I'm going to use tag and message, and I'm going to send a new line at the end, and I'm going to use the same for each one of them. Now that we have everything created, let's see if it works. So this is a live coding session, so there is always a big possibility that I've done something wrong. Hopefully I didn't. But let's open, for instance, our message fragment. And you can see that I've got a couple of logs here. For instance, when I receive new messages, I'm just going to replace log by Gutenberg, replace all. I'm going to remove this import and import the correct one. Perfect. And I'm going to change this log because I only receive one argument. So I'm going to call it here error. And everything should be working fine. So let's hit compile. Let's open. Let's wait a bit for the project to compile. And while it's compiling, of course, we can do the same thing for iOS. So I can just move to my other screen. And here on iOS, let's grab an example. For instance, this is the load message. Instead of using print, I'm going to use Gutenberg. The project is still compiling, so probably I won't have access to the method yet. So let's wait a bit for the project to compile. This is always the best part of live coding sessions, that we'll need to take a moment to see that everything is working. System UI didn't like me, no problem. And we can see that we already have our Gutenberg system working with our fancy new emojis. So with this, we created a logger that is common for both platforms, and it can have our own custom message. In this case, it has emojis. So let's just see if we do the same thing for iOS side, Gutenberg.d, and let me just try to understand. Gutenberg.d. And she wants to import Gutenberg. It should be inside shared. Let me just grab this definition. Let me just force the iOS project to compile so I can grab the new framework, and hopefully everything is done all right. This is the most tricky part. It's when you need to wait for the project to compile. Sometimes the IDEs leave some cache behind and you need to force the compilation to have direct access to what you're going to use. While the iOS project compiles, I can show you that you could also compile it from the Android Studio. You still need to have Xcode tools installed, but you can go to Edit Configuration and can add a new configuration that it's going to be an iOS application. This means that you can run the simulator directly from Android Studio. I typically prefer to have Xcode because of the syntax highlight and because I'm already familiar with Xcode, and I find it easier to do it this way. Another advantage here is that you can, to develop the UI, you can take advantage of everything that Xcode already gives you. The worst part here is that Xcode is a bit heavy, so having to add two IDs at the same time might lag a bit your computer. So fortunately it works. I already have my Gutenberg library. I'm going to call the tag. I'm going to use the tag, let's say, shot view controller. I'm going to use as message this print. And then I'm going to compile it just again. And let's see if everything will also work on the iOS side. Project is compiling. It's just a small change, so it won't take long. Moment of truth. Give me some drums. And it works. Nice. As you can see, we've got our logger working perfectly fine, both from Android and iOS, and this was just step one. So let's get over once again here to the Android side and see typically system UI. I've got a tab here that says conferences, and we're going to fetch a conference list from the network. So basically, we want to download a list of conferences. To keep things easier, I just created a gist on my GitHub, and you've got all the conferences there. So I've created here an object for the conferences. If you go to data, you've got here the conference object. It's going to be serializable using Kotlin serialization. And basically my JSON file has a name, a city, a country, a date, a logo, a website, and a status, basically saying that if the conference is online or it's canceled. So let's fetch this data, okay? So let's start by creating a new class. We go over here to data package inside our common main, and we're going to create a Kotlin file that's called conferences API. I'm going just to copy the direct link for the conferences. This is all available on my GitHub, so don't worry about it. Basically, I've defined the base URL and the endpoint where my gist is. And now I'm going to create the class conferences API. For this, we're going to use Ktor, and Ktor uses an object called the HTTP client. So just let's create val client. and call HTTP client. On the newest version of the lib, you don't need to define engine. This is automatically done for you. You just need to create an HTTP client. Now we need to create a method to fetch this JSON file from my endpoint. So I'm just going to call a fetch conferences method and say that client.get, and I'm going to use now it's going to ask the type of response that I'm going to receive. Typically, you should write here JSON. But unfortunately, since I'm hosting this on Gist, the content type when you make this request, it's going to be text plain and not JSON. So you're going to need to define it as string, and we're going to do the parsing afterwards. So my well-constructed URL is going to be base URL endpoint. And with this, we define our conference API. Now that we've got it defined, let's move over to our domain layer and create our get conferences method that's going to make the requests. So Kotlin file class, let's create get conferences. Once again, this is being done on my shared model. So this code is going to be common to Android and to iOS. I'm going to just define here a tag. Just we can make use of Gutenberg also from our shared project. Let's create our get conferences. So we need to receive a conferences API, which we've just created. We're going to create our invocation. And we're going to receive here two calls. That's going to be the list of conferences in case we're able to receive and parse our conferences list. That's going to be unit. And we also need to receive on failure. So in case something happens, for instance, you don't have network, so the request will fail, we can just say that, well, it failed. And the UI can respond accordingly. Okay. Although you can make some logic here, I'm just going to use try and catch for this. Once again, if we don't have network, we should make these checks before. But since this is a live demo, I'm just going to say that, okay, if something fails, I'm going to call on failure. So let's start by making the request. So I'm going to save it to a non-variable here called result. So we received the conference API, so let's call the fetch conferences. Now that we have the conferences, I want to parse them to have it on my conference object format. Once again, this could be done before, but I couldn't do it because the content type of the GitHub Gist, it's text plain and not JSON as I was expecting. So I need to do it here. So JSON dot decode from string. And if I'm not mistaken, it's this one. Exactly. So this is going to be, I want it to be a type of list of conferences, and I'm going to send here the result. Of course, I'm going to make use of Gutenberg that I've just created. I'm going to define it here, my tag, and I'm going to say that result is a list of conferences. Now that I've got all the information, I'm going to notify that this information is now available. So I'm going to call done success with a list of conferences that I just parsed and made available. Now that we've got everything defined, we need to create a presenter so our UI can access to these methods, or the UI can make these calls. So let's get over to presentation and let's create a conference list presenter. So Kotlin file class, conference list presenter. Let's start by defining the class. And now we've just defined the get conference. So let's just say that we're going to receive the get conferences that we previously defined. You saw that we're going to use coroutines. So for this, let's just also receive a default dispatcher. So coroutine context, and we're going to use the default dispatcher that we've already have. So now the important part is that I need to have some kind of way to say to the UI, okay, there is new data available. We could do this from different ways. From the easiest way that I thought of, it's let's make use of interfaces. iOS support this, Android support this. Of course, we could also make something different by using live data or something like that, although we're going to need a new library for iOS. But since we're following an MVP approach, I'm just going to create an interface here that I'm going to call it iConference data. So the UI can implement it, and once this information is available, I can just notify the UI that there is no information available, upload your list, or show an error with it. So let's just create iConference data. So this is going to be an interface iConference data, and we're going to have two simple methods, onConference data fetched, that is going to receive a list of conferences. Okay. And of course, we always need to have a method that says that, well, my request failed, so onConference data failed, that receives an exception. And if you look closely, you can see that, well, this is basically what we created on get conferences. As you can see, if you go to get conference, you see that on success will trigger this list conference, and on fail it creates an exception. Well, it's exactly this that's going to be called on our presenter. So let's move to the presenter and just create a global variable for my iConference data that UI needs to fetch, to set. And I'm also going to create a scope for the coroutines. I'm going to create a method here. I'm going to call it attach view, but I could just call it anything that I want. And basically, it will have this iConference data. This is going to be set by the UI itself, either by Android or either by iOS. And I'm going to grab this interface that I'm going to receive, and I'm going to say that my view is going to be current view. My scope is going to be the presenter coroutine scope with my context, and I'm going to call then the fetch conference list. So let's create this fetch conference list. Basically, you saw that we received this get conference that we created before. So let's just call these conferences and define what unsuccess means. So basically, it's the method that we create on conference data fetched. And let's also define what failure really means. That's our on conference data failed. So basically, we're going to send this to the get conferences. And once again, when conferences are available, they will call on success that will once again fall back to our on conference data fetch that in terms is going to update the UI. So now that we've got everything defined, we can go to our service locator to implement a method that the UI can call. So let's start by initializing a couple of variables. So we need to have our conferences API. I'm going to define it here. So this is an object, so it's not needed to be created over and over again. We can always use the same object. I'm also going to do the same thing to get conferences. And I'm just going to define the getter that's going to receive the conference API that we've created before. And now I'm going to create the get conferences presenter so the UI can call this to initialize our presenter. So this is the conferences list presenter. And once again, we're just going to define the get on conferences list presenter with the get conferences that we created before. And from our shared model point of view, we already have everything defined. So now that we have everything defined, let's call these methods from the UI. So this is done on the conferences fragment. So let's go over the UI and let's open our conferences fragment. So basically, this is really simple. Just here a fragment with a list association. So let's start by creating our access to our presenter. So presenter conferences, we're going to use by lazy. And remember that we've defined everything on service locator. Well, so let's call service locator and automatically call get conferences presenter. So we can initialize our presenter conferences. We now have a method here called setUpView where we define the objects to initialize the UI. So we're going to call it here the attach view that's going to make the request. So remember this attach view? This is the attach view on conference list presenter that's going to trigger the fetch conference list. This attach view receives an interface, so we need to define it. So let's get over here and say that I'm going to use the iConference data that I've just created and see that it will automatically load it from my shared model. Once again, I'm just going to press Alt-Enter or Option-Enter to automatically create these methods. And what I'm going to do here is just to save them on my list, my recycler view. So I'm just going to get adapter, RB conference adapter as conferences list adapter, and I'm going to submit this new list that I've just received, conferences. In case it fails, I'm just going to call Gutenberg error tag enable to retrieve conference data. So now that we have everything created, it's that moment of true time where we're going to compile the project and hopefully everything will work just fine. But remember, once again, this is a live demo, so there's always that small chance that Murphy is against us and we can need to make some last minute fix. System UI not responding, no problem there. I'm just going to compile it, it installed. Let's just see conferences, and we've got conference. Great job, everyone. We've got our list of conferences here. I'm making network requests to access my GitHub gist. Glide is just outputting some message, and we've got here everything. Here it is. Our get conferences with the JSON. Now that we've done everything on Android and we just tested everything was working fine, let's go over the iOS part and do the exact same thing. So we just need to implement once again a service provider. So let's go over conference list. Let's start by creating our iConference status. So I'm just going to go here, create an extension, conferences view controller. I'm going to say that it's iConference data. I need to compile the project to have access to it, but don't worry. Func on conference data failed, Kotlin exception. On conference, I was trying to write Kotlin here, but it's Swift. On conference data fetched, we're going to receive the conference list. So list, exactly. In this case, I can use Gutenberg to output, to print an error. So I'm going to use, I can use a warning. Oops. And now when we have all the information available, we're going to say that self-conferences is going to be of type of conferences, and our table view will reload its data. Now that we've got our iConference data defined, don't worry about the errors. It's because I didn't compile the project yet, hopefully. And now let's create the same thing as we did on Android. Let's create our presenter conference from service locator. So private let presenter conference. We're going to access service locator. We're going to call init and that get conference presenter. Now we're going to call the fetch on, it's not on because we're on iOS, it's view div appear, exactly. And now we're going to call presenter conference and we're going to call attach view where the current view itself. Now just let's it compile and it will fetch the new framework with these newly methods, and hopefully this will also work without any problem on the iOS side. As you could see, I've implemented this shared logic basically just on my shared model, and I'm going to make use of it on Android and iOS. I just need to define the UI. I've defined the table view, the recycler view, the items, and of course the interface needed to update when everything was failed. What happened? Some typo. It's conference presenter. Okay, small typo. Let's just hit compile again. So I just need to implement the UI. I'm just using the shared model as I was doing it before. Just let me launch the simulator. Let's just open the conferences tab, and that's it. Everything is working. I really love when everything works. So let's go to the next step. We're going to store this data locally. We can take advantage of everything shared to just implement this locally. So let's start by going to, let's close all of these tabs and let's open build.gradle. We're going to use the SQL Delight for this, and the small thing here, we need to define the database name, where it's located. To keep things easier, I've already have this SQL Delight data folder created and the model. We're just going to create our table. It's a bit different that if you're already familiar with Android. So we need to create a new file and we're going to create a SQL conference model file, conference model as key. And now we need to define how we want to have our tables. So if I'm not mistaken, this is going to be something like this, conference model. And to make things easier, I'm just going to open here my conference. And let's start. I'm going to say ID it's text not null, and it's the primary key. Then we've got name, which is text not null. I'm just going to copy paste this part. City. Then it's country. Then it's date. Then it's logo. Then it's website. And then it's status. Now that we've got everything, our table here created, we need to define the methods for insert or replace conference. So it's going to be insert or replace into conference model with ID, name, city, country. I can just close it now. Country, date, log, website, status, exactly, with values, and we have got 8 fields. So for, let me just confirm that I've got everything right. For and for, exactly. And of course, we have added the insert or replace conference. We also want to add the select all conferences to get all conferences from database. Conference model. And that's it. We've got our conference DB created. I'm just going to hit compile to confirm that everything is working fine. But before we dive in, I'm not hoping, okay, it was able to parse, so I didn't have any error here, which is also great. As I've hit compile, it will generate all the files that I need to access my database. But let's start by create a new platform class. So once again, we are on our common main, and since I need to define the drivers to access the database, I need to create a platform database, meaning that this is going to be defined on iOS and on Android. So I'm going to call it platform database. And I'm going to say that I expect, once again, someone to define what platform database is. So someone needs to define this create database, which it's going to be a conference DB. And this conference DB was already generated by SQLite. This is why I hit the install and compile first. Of course, now he's going to say, oh, if you press Alt Enter, oh, you need to create what platform database means on the JVM and on native. So let's just Alt Enter and enter again to say what create database is. I'm going to create here just a small method to help me. So I'm going to create a create driver. It's going to be the type of SQL driver. This is the drivers that are going to be used internally to access the database. So SQLite already gave us everything that we need. So Android SQLite driver, conference db.schema. I'm going to need a context. This requires an app context. If we dive in, this requires the context that we typically use on Android. So I'm going to define here a late init var called app context, and it's a type of context that we're already familiar with Android. And we're going to define it afterwards, don't worry. So we're going to send it app context here, and we'll call it a database app.db. Now that we have this created, let's just call conference DB with the driver that we just created. Perfect. Remember that I've said that we need to create an app context, so we need to make a small jump to our Android application and leave the shared model, and let's just open app application, and we're going to call app context. And since we know that the application is the first class to be called, we're just going to define that app context is the context of this application, and that's it. App context equals to this. If we go over once again to the platform database, we're going to press once again Alt Enter, and it's going to say, oh, you need to define this once again, but for native, for iOS. So let's just click there. Follow the same approach by creating the driver, private fun create driver, SQL driver. And in this time, instead of returning an Android SQLite driver, it's going to return a native SQLite driver. So let's get the conference DB schema. We don't need the context because we don't have it on iOS, which is great. And we're going to call appdata.db. We make the exact same thing. We call the conference DB with this newly created driver. And that's it. So if we go over to the platform database, it's going, oh, I made a typo. Platform. We're going to just call it here. I need to update the name on each one of the files. Unfortunately, it doesn't rename it all. Platform, perfect. And let me just open the iOS common Android iOS main. Okay, perfect. Common main, who's missing? Shot the VM, it's missing, so perfect. Now we've got it. Now let's get over to our domain, and we need to create a DAO to access the database. So let's create a conference DAO. Conference DAO. Let's create our class conference DAO. It receives a database, a conference DB, and we're going to access our DB database.conference database.conference model queries, and let's create those insert or replace and select all methods. So fun insert or replace, we receive our conference. db.insert or replace is going to ask for an ID. We're going to use the ID something simple, so we're going to just use the conference name for this. Although we could auto-generate one or something like that, there's no problem. I'm also going to use for name, we're going to use conference name. For city, the conference city. For country, the conference country. Date, conference.date. Log, conference.log. Website equal a conference.website. And status, conference.status. Now that we've implemented the insert or replace, we need to do the exact same thing to get all conferences. Once again, it's the same approach. Let's get all conferences, and this is a list, so let's call it a list. val conferences, it's mutable list of conference. Let's just get all the items. Conferences, let's add this new conference object, item.name, item.city, item.country, item.date, item.log, item.website, item.stats. All done. And now let's just return the conferences. Basically, once again, we've created our insert and replace. This can be called from the UI, and our get all conference, so we can have access to all the conferences. Now we've created a method called a class called get conferences. So this is the perfect place that we can use to store the conference on the database, right? So before we call on success, we can get conference in conferences, and let's just add them to the database. So we need to get our DAO before, so we're going to also receive here the DAO that we've just defined, private val DAO. It's a conference DAO, here it is. And now we're going to call insert or replace conference from the DAO. Since when we don't have internet, this catch, it's going to be called. We're going to do something different here. And if we don't have internet, but if we have conferences on our database, we're just going to return them. So if conferences is empty, we're going to call on failure, no conferences on database. But instead, if we have conferences already saved, we're going to return them here. And now I only need to go to my service locator and define this conference DAO. So private val conference DAO, the exact same thing. We're going to call by lazy and create our conference DAO that receives our platform database, create platform database, create database, what happened? I think it didn't like for some reason. And then we're going to send the conference DAO here. So conference DAO receives the database, conference DB, that's correct. Let me just open here our service locator once again. Platform database, it's here. Okay, create database. It's also fine. Create database, conference DB, and let's just hit compile to understand if everything is correct or if I'm missing something. Okay, expect it's correct. Platform database, also create database. Operation succeeded. Okay. Sometimes this happens. Once again, don't forget that this is alpha version of Kotlin Multiplatform. So sometimes you might see an error that it's not an error. So let's open conferences. It's going to fetch the list. Okay. Now I'm going to disconnect the Wi-Fi. My system UI just died. No. system UI. Okay, I can go it by here. So let's go open settings. Wi-Fi, I'm going to disable. Wait. Dear system UI, don't you want to appear? Okay, it seems that my setting system UI is not working as it should. Don't worry. Just to show you how everything is working, let's get over get conferences. And instead of making this request for the API, I'm going to return it directly from the database. I'm going to do it here. So basically, instead of fetching it from the database, since we already opened that view, we already added them there. So if now I'm compiling the project, hopefully if the system UI doesn't decide to work, now if I'm compiling the project, if everything is working as expected, it will fetch the, okay, perfect. It fetched the conference from the database directly. So they're currently being saved. The cool thing about this is that we've implemented this on Android, on the shared model, and it will automatically be available on iOS. We don't need to do anything else. We just need to compile the project, and everything is granted for free on the iOS side. Now that we've implemented the storage, I just wanted to create a small thing more. I'm going to create a platform settings. So I'm just going to create a new file just for you to see how we can define a specific username. For that, we're going to create these platform settings. And I'm going to say that I expect someone to define what platform settings is. So we're going to have a settings repository. And we're going, and we're going to create the settings repository. What we're going to have on this settings repository, it's really simple. I'm just going to open on my shared model data and create this settings repository. So basically we have that online, for instance, setting. So I'm going to create that constant setting only online. And we're going to call it setting show only online. And we're going to create our class settings repository. Damn it, I'm eating words. Repository fixed. So this is going to receive a set of settings. And this logic is going to be common once again on Android and on iOS. So app settings, it's going to be type settings. And we're going to create these app settings with the settings that we've just received. Create app settings, which will return settings. You guessed it right. And we're just going to start there the online one. So we receive the settings. We're going to say that show only online. It's going to be a Boolean. So we're going to set it as the key, and the default variable it's going to be false, and we're going to return these newly created settings. So we can also create two methods for this, one to get the settings value, so we don't access this value directly. So we can create a fun should show only online conferences, and we're going to access our app settings and get the boolean that we just created, setting only online. Of course, you can always apply and change this value, only online conferences, state boolean, app settings, put boolean settings, only online state. It's really similar to what we already use on Android side. We just need to create it on the shared model, and with this we use it without any problem on both platforms. So we said that we're going to use the settings repository here. We also said that we need to define what this is going to be. So let's create what the platform settings is on both Android and on iOS. So this needs to be fun because we're returning this. Perfect. So once again, Alt Enter. Let's open GVM. Let automatically create everything. So settings repository, we're going to define it by lazy. Only need to access it when we open that view, and it will create the settings repository that we've defined below. Here, we're going to make use of Preference Manager. So we're accessing Android code here, Android X Preference Manager, get default shared preferences. We're going once again to make use of app context. And now we're going to create what we're going to call the Android settings. This is already available on the multi-platform library created by Russ Wolf. It needs to receive the shared preference object itself, and you just now need to return settings repository and the settings that we've just created. Now, if you go over the platform settings once again, we need to do the exact same thing for iOS. So create native. We're going to call here once again by lazy. We're going to call once again create settings repository. And here we're going to instead return settings repository, but we're going to use the Apple settings. Since we are on iOS, and yes, user defaults, and yes, user defaults, font standard user defaults. Perfect. Now that we've got everything ready, we're just going to open once again our get conferences that we have on our shared model. So get conferences, I'm going to remove this database hack from here. On get conferences, since we only want conferences that are available, we're going to create a new variable, available conferences. And we're going to say that if this setting is on, so if settings repository should, thank you, should show only online conferences, we are going to filter them by just showing online conferences, conference.filter. It is not cancelled, else we're going to return the conference list. Now, instead of sending the conferences, we're going to say to send only the available conferences. Now that we've done here, we need to go to the Android application. So let's go over fragments, and we are on settings fragments. So the user can change this value. So let's start by checking if the checkbox should be enabled or not. So binding.cbonline is checked. It's all settings repository, should show online conferences. And now we're going to do the exact same thing for when this value can change. Set on checked, change listener is checked. Settings repository only show is checked. Perfect. Now, if I'm going to run the project, it should work fine on the conferences. Let me just compile this. The application is compiling. System UI isn't responding. This emulator is going really strong. Okay. Conferences list, it's loading. Okay, perfect. Now let's see if we've selected online conferences, and that's it. We're able to select only the online conferences. Everything is working fine. We just needed to implement this on the Android side or on the shared model side, and it automatically is available everywhere inside our application. So we've got this tutorial as a couple more steps that you can follow. You can migrate code to multi-platform Firebase. I've got here a couple of links in case you need to troubleshoot everything. And in case you have any questions, please don't hesitate to ping me on Twitter, or if you need any other thing, don't forget that you can always reach me here via droidCon, or you can just send me an email, or can just open an issue on the GitHub. So it's time to see if we've got any questions. This is also opening, so I'm expecting that you can always if you have you already have one question. Nice. Any caveat when using Kotlin routines in iOS? Yes, so many. Good question. For instance, basically, I needed to, since coroutines aren't available on iOS at this moment, or better, nowadays, I think this branch is already accepted and you have a native empty version of coroutines. But when I started to create this project, I needed to use a branch that wasn't yet merged with the latest version, and I needed to use a specific branch in order to access these coroutines, and with Kotlin on iOS. So basically, I couldn't take advantage until the full potential of coroutines until I use that branch. I can just show you what the name of the branch is. Native empty, just a second. I believe you can see my screen, but I can share this afterwards. When you, a couple weeks ago and a couple months ago, if you want to use coroutines on iOS, you were single-threaded. You couldn't really take advantage of coroutines. So basically, JetBrains created a branch called Native Empty that you could use coroutines. It was still experimental at the time. And if you want to use it with Kotlin, you needed to make a strict version on this branch. If I'm not mistaken, this was already merged with Eval, and you can now use it without any problem. And you just need to call this a native empty to take advantage of everything. Thank you, Havajir. I'm not sure if I pronounced it right, but thank you. Can you implement actual function in Swift? No, you can only do the actual implementations on Kotlin. This needs to be done on your shared model. You cannot do it on Swift. For the Swift part, what you can do, it's just to implement the UI. All the UI typically is implemented on Swift, on Android, and on Kotlin. Of course, there are, since this opened the doors to a lot of possibilities, I already saw some projects. Thank you, Anonymous. I already see some projects that that I've Kotlin Multiplatform working with Flutter. I've tried to do the same. It's not the best experience out there because it takes you some time to set up the whole thing, but it's possible. But once again, this is not the goal of Kotlin Multiplatform. The goal is to have your business logic on a shared model and then to implement it the UI natively. I've already mentioned that JetBrains is giving a really great push on Kotlin Multiplatform. If you look at JetBrains roadmap and the latest versions, you can see that they are really making a lot of improvements on the multi-platform. So I believe that we're going to have great things this year. This year, the next year. There are a couple of links also on my slides if you want to know more about Kotlin Multiplatform. There are a lot of excellent projects out there. TouchLab is doing an amazing project. They have the Camp Kit. It's a really good starting project. We also have John O'Reilly with a couple of projects that are really, really good. And he's always updating everything. In case you have more questions, you can always ping me on Twitter, ping me here on droidCon, just send me a message. I hope you've liked it, and I hope to see some new projects on multi-platform next year. Feel free to tag me if you do. And happy holidays, everyone.